So today we are presenting on an installation project. We were tasked with the task of creating some sort of insulation to go over a 1-inch box to determine how much heat would be kept inside of it.
So some of the building constraints that we had is we had to have a composite material that would produce minimum heat loss, and it must have a thickness of less than or equal to 1 inch. We also had to, the composite material also must have a constant internal composition. So for our next one we used like shredded paper and aluminum, and that has to be environmentally friendly, must be recyclable, and must be economical.
So the materials for our
Go past the first one.
our materials for insulation were so it was shredded paper and aluminum from a pop can. So there's all manner of bank documents and credit card statements and stuff in this insulation. And there may actually be a shredded credit card, so it's not entirely paper. Sorry, guys. And there's our beautiful, beautiful insulation. Like that.
Yeah. So for the calculations, we had energy that was gained in the box. We took the mass times the heat constant times the maximum temperature of the box inside the box minus the initial temperature, which gave us to 155.109 joules. The energy lost in the box was again the mass times the heat constant. But this time multiplied by the final temperature of the inside of the box times the maximum, which gave us a negative 80.46. The efficiency was, of course, taking the energy gain added to the energy lost to get 74.649, and divide that by the energy gain to get us 48.13% efficiency in keeping the stuff in the box. It was a little higher than what we expected, considering how jumbled up everything was, but it turned out okay.
So for the basic stats for our construction is our initial internal temperature was around 22 degrees Celsius. Our maximum for our internal ended up getting around 57 degrees Celsius, and our final was 39 degrees Celsius. So our initial box temperature ended up being somewhere around, or our change in temperature ended up being around 30 degrees or so, or 20 degrees or so, which was pretty good. And here's our calculations for percent retained.
Alright, so we also had another installation which were these gym shorts, except not exactly those gym shorts. And there it is. This was done like literally in the middle of a physics class.
So again, for the calculations, we of course took the same two initial values of the mass and constant, but this time took it to the maximum temperature, which was 63 degrees, so it's increased, and the initial temperature of 22.5, which was about what it was before. We got 181.035 joules, which was a higher one. Then we took the same equation, this time plugged in the final temperature, which is 42.1 minus 63, which got us a negative 93.423, which was also higher in turn. And using our efficiency equations, we got 48.4%, which was just slightly higher, but that could be due to the fact of both values increased somewhat proportionally. So it ended up being about the same amount.
So as Tony said previously, we did have a higher max internal temperature, and we also had a higher final internal temperature. Our room temperature actually stayed lower than our first one, and our difference in max room temps and internal temps was about 40 degrees-ish, and we ended up losing more energy, but we also gained more energy, which allowed us to get a slightly higher efficiency rating. That's our insulation project.
Okay.